International Space Station is the largest and most complex international scientific mission in history. With this orbiting laboratory, there will not only be new advances in space technology, but a chance for all types of different scientific fields to have new theories tested and experiments completed in space environments. And not all of these experiments will be tested inside the station. NASA is conducting experiments outside the International Space Station with a new project called MISSE, or the Materials International Space Station Experiment. The first experiment mounted externally on the International Space Station, MISSE will investigate the effects of long-term exposure of materials to the harsh space environment. MISSE will also evaluate materials currently being used and those planned for use in future space missions. I spoke with Dr. Bill Kynard at NASA Langley Research Center to find out more.
MISSE is a technique to utilize the space station to do space exposure experiments. Of course, the name says it's a Materials International Space Station experiment, but it's a lot more than that. MISSE is not one experiment, but actually it's a collection of over 1,000 different experiments. MISSE involves some passive experiment containers that have been developed here at the Langley Research Center. And these are basically small suitcases. We can put test specimens inside these suitcases, close them up, and then we can transport them to space by the shuttle, take them out during an extravehicular exercise. We'll open the suitcases up to expose the specimens on the inside, and they clamp them to handrails on the space station.
Bill, you mentioned specimens. What sort of specimens are we talking about?
Sections of material, small pieces of material that we can expose in space that are large enough to let us understand how the space environment is going to affect them. Or in other cases, some of the specimens are components. Solar cells, for example, or electrical switches, parts of a fiber optic cable that might be used on a spacecraft. We are testing composite materials and ceramics and polymers that might be used to construct more conventional spacecraft. We don't have to modify the space station to accommodate these experiments. There are lots of handholds all around the station, and we can locate these experiments in various places. So it's a very economical mode to utilize the space station for some very critical type testing.
MISSE is a passive experiment, which means that aside from deployment and retrieval, no other interaction is involved. The two carriers will be retrieved approximately 1 year after deployment and returned to Earth on a later shuttle flight. Bill, why does NASA feel the need to do these experiments in outer space as opposed to here on Earth?
I think everyone is aware of the contributions we get every day from satellites in space. But I don't think people are aware of the fact that the environment these satellites have to operate in to give us this information every day is an extremely hostile one. Space is composed of harsh vacuum. This vacuum can change the composition of materials that spacecraft are made from, and this changes the properties of these materials. Spacecraft are exposed to unshielded, harsh ultraviolet radiation. And this radiation can very quickly darken and embrittle most of the plastics that we use every day on Earth. We cannot simulate these environments in the laboratory adequately to do testing to establish whether materials can function in space.
So what happens to the materials when they come back to Earth?
We get them back, we'll bring them into a clean room such as this, and the investigators will look at it, and the first thing they'll do is establish whether or not the materials survive. Was it completely destroyed by the exposure in space? If it survived the space exposure, then they will do testing to see if it still has the unique properties that are needed for future space missions, and see whether or not that it can function and deliver the data over the extended mission that's required. Hopefully with MISSE we get adequate data on these materials so that the designers can select the right materials and be confident that the spacecraft they design and build will function.